All right, we'll go ahead and get this webinar kicked off here. So welcome everybody. Good morning or good afternoon, depending on where you are in the world. Today we will be discussing work queues. And one of the first things that comes to mind when I think about why you would need a work queue is batch processing. So we will actually spend some time today conceptually talking about other design patterns that are equally important when it comes to handling large batches of data. Now, for those of you that are new to Decisions, we are a business process management software that helps non-technical people, such as myself and Kyle, to easily automate and optimize business processes without the need to code. Now, on this slide, we have some of our current customers in different sectors to give you an idea of where Decisions fits. And we are equal parts rules engine and workflow, so there's a lot of different problems we can solve across different industries. And today, here are your presenters. You can hear me speaking. I'm Jessica Potter, and here's our lovely headshot so that you can match a name with the face. And go ahead and say hi, Kyle.
Good afternoon or good morning or good evening, everyone, wherever you are in the world. My name is Kyle Bachner, and I'll be the other sales engineer running this webinar today.
And we have had the pleasure of meeting many of you on webinars or video calls in the past, but now we're about to discuss some of our upcoming events. So come and experience us virtually. Now, we also do welcome connections and questions on LinkedIn, so please feel free to add us there.
So we're just going to talk about some upcoming events real quick, just so you guys know what is, well, upcoming. So first, in the beginning of March, that is the 2nd through the 4th, we have our beginner training track, and that will be in Eastern time. So this will be for those of you who have never built anything in the tool, and will teach you how to use the 5 primary designers within Decisions. On March 11th, we have our next webinar, and that will be on mobile forms within Decisions. So we've recently had a major overhaul to version 7, and this webinar is going to go over how users can design forms to be responsive and used on mobile devices. And then in the middle of March, that is the 15th through the 19th, we are doing our professional certification course. Now, in order to take this course, you do have to have the associate certification or that course passed in order to take this one on. And it's just going to be a little bit more complex and going into advanced usage of Decisions. And then at the end of March, the 23rd through 25th, that is our beginner and advanced training. And that advanced training course is looking at the project requirements for actually creating things in Decisions, so you get a better idea of how to use the tool and build your process in it. Now, when you guys sign up for these, just make sure you pay attention to what time zone it is offered in, so you can make sure you sign up for events that are most convenient for you.
Those really sound like some fantastic events, Kyle, and I really hope that we see you guys there. Now, let's go ahead and take a look at our agenda for the next 45 minutes or so today. And as mentioned before, we are here to talk about work queues. So we're going to kick things off with Kyle answering the question, what is a work queue? If you have no idea, don't worry, we will get you there. Again, as mentioned before, when we think about work queues, we think big data, and big data means batch processing. So we want to cover different ways you might be able to handle batch processing without necessarily using a work queue. Now, after covering different design patterns to handle big data, we are going to dive into the product and show you step-by-step in Decisions how to enable the module that allows for work queues, how to configure those settings. And then for the big dog and pony, Kyle is going to walk us through a simple build that is utilizing work queues and run it live for us. Now, as always, we will leave plenty of time for Q&A at the end. However, if a question comes up during the presentation, please feel free to ask it right then and there, as it might help shape our conversation today. Now, speaking of Q&A, Kyle, can you walk us through the Zoom panel and how our participants can interact with us?
Sure thing. So at the bottom of your screen, you should have this Zoom panel in the window that you have Zoom in. So we have just the basic features of chat and Q&A. So if you have any questions, feel free to put it in that Q&A, and we will get to those as soon as we can. So we're just going to move on since, it's a Zoom panel. We should know how this software works by now. And let's get into the topic of this actual webinar and talk about what a work queue is. So at a high level, work queues basically allow data to be segmented or broken down into chunks. Once we have this chunk of data or these chunks of data, then it's stored in a queue and worked on in whatever logic the user defines it. And yes, we will be recording this webinar and it will be available at the end of this up on our website. So back to work queues. So in decisions, work queues allow multiple servers to do work on the same queue. So this is done by utilizing the capabilities of multi-threading in a clustered environment. In order to use work queues, you do have to have an enterprise license. Even if you don't have an enterprise license, this webinar is still for you because we'll be covering other ways to handle large data sets as well. So we have some diagrams at the bottom here just to give us a better visual of what a work queue actually is. So on the left, we just have a representation of a queue that is distributing work to its workers. In a situation like this, ideally you would be using something like a load balancer in order to manage that work that is being distributed. So that way, as soon as a worker is free, it can immediately be handed the next job. Then on the right, we're showing a bit more of a drilled down view of how this process is actually managed. So when a thread is free, new work will be loaded in and then passed out when it is done. So now that we have a bit of a better understanding of what a work queue actually is, let's talk about the different patterns for how we can handle batch data in decisions.
Now we will be jumping back to those work queues, but again, we do want to cover a typical batch data handling scenario and some different design patterns. Now, no matter what pattern you use in decisions, there are these macro stages that you need to think about. One of them is, how does the data get into decisions? Is it being pulled? Is it being pushed? What's the format of that data? It could be on a file of some sort, or it could be coming directly from a database. Either way, you need to get data into decisions. Then you need to do something with that data, do work on that data, run it through rules, add fields, change fields, manipulate that data. That's what you're going to be using our workflow and our rules engine for. Now, after you perform the work on that data, in 99.99% of scenarios, you are then going to want to save that data off or send that data somewhere else. You're not just going to discard it, or else, what was the point of doing that work? And then finally, you're going to want to see the results, maybe report on those results, or maybe drill in and do some deeper analysis on it. Now, one of the important things to note here, looking at that blue box that has appeared on the screen, and what we're really suggesting here is that when you're doing batch handling, you've got records. In our case today, we'll be looking at sales records, but this could be a number of different things, maybe medical billing records or manufacturing transactions, project tasks. It doesn't matter. There's the act of getting that data into decisions to start to use the rule engine and the work engine. But then that's one set of things that you need to consider. Now, doing the work on each of those records and saving that data or sending that data somewhere else, so phase 2 and phase 3, that's always done in decisions, where phase 1 and phase 4 might be done in flows, or it might also be done with some partner technology, such as a messaging service or API calls that are going to push that data in. So really, we just wanted to bound the idea that in each of these 4 phases, there are multiple considerations you want to think about. And our main focus today will be on phase 2 for patterns of doing the work in different and efficient ways.
So one of the ways that you might be doing that first step, which is actually getting that data into decisions. So we're just going to talk about how you can actually load your data. So you might not be using, decisions specifically for that, but it's still important to talk about how you can get that in there. So in order to get work done, we do need to have our data to work on. So one of the ways you could do this is using one of the built-in connectors to integrate with an external system. That is using one of Decision's modules that comes out of the box. This could be using maybe the RabbitMQ or the Kafka module. So you can go ahead and connect to something that already has that built-in connection. Additionally, we can connect to anything that has an open API layer or open database connectivity. So that way you have a way to actually send in your data from an external system. If somehow these options don't manage what you're trying to solve or solve your data migration problems, then we do have a software development kit available in SDK that will allow you to write custom steps to connect to an external system, and then you can use those steps in your workflow. So another way, instead of just pushing in data from an external system like APIs and such, another way we could get data is to pull it into decisions. So that could be fetching from an external database, or we could be using steps such as uploading a CSV or an Excel file into decisions. So once we actually have all this data loaded and fetched, we could start to do the actual work on it.
Now, before we talk about the different patterns here, one thing that's important to note is a principle just in general when you're using decisions is that using subflows is a very effective way to break up your project into smaller, more understandable chunks. So this is going to allow you to unit test each of those chunks, but more specifically, when we start to get into these patterns of batch handling, if you're worried about how to identify or decide which pattern to use or try in a project that you might have in your environment, by simply encapsulating things into a reasonable sized chunk, you're going to be able to adapt and change which pattern you're using a lot more easily.
So we're just going to talk about some of the basic usage patterns real quick for getting work done within decisions. So starting at the top and then working our way down, we are increasing in complexity for those use cases. So again, these are just some of the basic patterns. And starting at the top with our sequential process, this is if you're building a process where maybe you're working on small batches of data and you might not actually need to use work queues at all. A simple loop might be good enough or efficient enough to actually get all the work done that you need, and you might not need the additional processing power that the other patterns will use. As we talked about before, there are also ways to fetch data to actually pull it into decisions. So this can be done, via API or through a message queue or message bus. We could also just upload an Excel or CSV file and into our workflow to load that data. Either way, once we have it in the system, we can run it through whatever logic we have designed. Other ways of doing work on this batch data without using queues include what we like to call asynchronous subflows. And these are just subflows that work in a fire and forget way. That is, instead of running through each loop sequentially, they are actually executed all at once, and then the system treats it as a thread job. So that is, a single server could have multiple threads that are helping with this processing. This can lead into more complex patterns such as leasing and the main topic of our webinar, work queues, which can specifically allow multi-threading across multiple machines to do work from a queue.
Now, we will take a deeper dive into each one of those patterns just to kind of drill in those principles a little bit further. But before we do that, let's talk about some of the different attributes for the different pattern styles. So for a sequential process, you can have a clustered environment, sure, but the machine that started the sequential process will be the machine that does that work. So you're not going to be distributing that load across a cluster. One thing to note here is that if there is a reboot in the middle of the process, that data will not persist. This pattern is available for all license types. Now, moving on to kind of the feed data category. When you have a feeding pattern, whether it be that API or messaging service, you can see for a clustered environment, we have a check and an X. And all that means is that by default, when feeding these messages to decisions, the same machine is going to do that work. However, you can do something like set up multiple nodes behind a load balancer, and now you have multiple nodes doing that work as they become available. Does it survive a reboot? Yes, absolutely, because we are only doing work on one unit of record at a time, and we haven't fed all of that data into decisions. Now, for enterprise, again, this is a yes and a no scenario. If you want to sit behind a load balancer that will require the enterprise license. However, if you're using this pattern to just feed data directly into a single machine, then no, you do not need that enterprise license. Now, moving on to async subflows or kind of the run flows for list, either one of those patterns, yes, you can have this work across multiple servers, but I would maybe put like an asterisk next to this checkbox, because in general, you will be processing those on the server you started them on. Now, just know that the data is not going to survive if the server is rebooting in the middle of the process, because again, it's all that data is living in the memory of decisions. So if you reboot it because you've loaded it all in at once, it's not going to survive. Now, again, you do not need the enterprise license to work with one of these patterns. Moving on to worker threads. This is going to allow you to launch a thread off, and the thread is getting data from an external system. And because we're actually fetching the data individually from an external system, then yes, we can distribute this work across a cluster, and it will survive that reboot because the data is being stored somewhere else. And then finally, dealing with queuing, where you are using the queuing functionality in decisions, it is cluster aware. So multiple nodes can be pulling that work from the queue as each node is available. And it will absolutely survive that reboot because again, you're storing that data in the queue. You're not storing it in the memory of the flow. So you're going to be able to, if the server restarts, just pick up right where it left off. Now, to use the queuing functionality, that does absolutely require the enterprise license. And again, we're going to go in and show you exactly how to set up this queuing.
But first things first, we're just going to talk about each of these patterns in a bit more depth, just so we get that context for, why would we actually be using a work queue? So the most simple of these patterns are that just very basic sequential process. So this would be something like a loop that will be going through each item, doing work, and then going on to the next item immediately after. There's no additional configuration that's going to be needed in order to run a process in this way. It's recommended that you only use this pattern when processing small amounts of data or when your process is very simple. For example, maybe you have a list of purchase requests that was less than 10,000 items, and you needed to route each item to its appropriate department and then task someone to manually approve or deny each request. This could be done by using a for each loop and then running each item through a subflow. In the background, decisions will loop through and individually process each item in a sequential manner. As things start to get more complex, we could start changing our design patterns to scale with the amount or complexity of the data that we're working with.
So feed via API. This is taking a flow or a rule for a single item and exposing it as an API. And you're going to have the service layer be responsible for triggering that. Now, you can get quite a bit of work done this way, maybe a couple thousand records. But would you want to feed 2 million records through one by one via API? No, probably not. You would want to consider another pattern because that external application is going to be responsible for the failure or retry logic. So if something goes wrong during that call, the external application needs to know to retry or to record that it needs to be redone later, or else you're going to find yourself with a serious data integrity problem. The unit of work is going to be the same for each of these calls. And really the only steps that you need to take here would be to just expose that flow or that rule as an API using the integration details that you see on the right-hand side of my screen. If you're interested in setting up integrations, calling into decisions, we have a webinar dedicated to that. Now moving on to the messaging pattern. This pattern is extremely similar, except you configure it a little bit differently. So for API, you're exposing that logic as an API, and you're configuring it with the external system. However, with messaging, you're configuring that handling logic inside of decisions. You register a flow that will be doing the work as a proper message queue handler using one of our message queue systems. And as Kyle mentioned before, we have a lot of out-of-the-box integrations to messaging systems, so it should be a breeze to set that up. But in both cases, it's the same concept. The throughput you are getting is really about the flow engine and the rule engine doing work on one unit at a time, while something else is feeding those units of work in. And I will also take another moment here to mention that if this pattern sounds interesting to you, we also have another webinar dedicated just to message queues.
Just plugging all those webinars today, aren't we?
I can't help myself.
Don't blame you there. All right, so the next pattern that we're going to be talking about here is our run flows for list step. So this step is fairly interesting. It basically acts similar to calling a subflow. It's going to allow you to pass in a list of items, then it will run each of those items through whatever subflow you built. Run flows for list is unique compared to a subflow because you can actually change its run behavior. As you can see in the screenshot, there are different behavior patterns that can be selected for this step, and we're just going to talk through how each of them works real quick. So for that synchronous behavior, that's when it runs in real time on the current flow or whatever thread is executing that workflow. Similar to how an in-session form is going to display to a user immediately, where as soon as that work is processed, it is done. So next we have that thread job when we are running it in a synchronous fashion, but also using multiple threads on the same machine to execute it faster. So this is just, again, multi-threading on a single instance instead of doing multi-threading across multiple servers. Next, we have that work queue option where this is going to allow that flow to run across multiple work queues and allow that load or that data being processed to be split. Thread job async is going to allow you to run that flow asynchronously, and it's not going to wait for any data to return for it to go to the next step in the process. Then async and wait is kind of similar to that thread job async, except it's going to wait for that run flows for list step to actually execute every item in that list before going to the next step in our process. So this step will allow you, again, to use that multi-threading capability on a single instance. However, unlike work queues, if an item fails, the work might not be able to restart. So it depends if you have actually built in that logic to handle that kind of behavior, whereas a work queue, because it is queued up, everything will be persistent. So for example, a run flow for CSV step exists, and it's going to act similarly to run flows for list. So we have steps that are kind of similar to this, but will work for different data types, which is that run flow for CSV step. But it's going to just run a process or whatever subflow we call through each line of that spreadsheet. So if you're dealing with spreadsheets, the run flow for CSV step might be more useful than run flows for list. But again, this just depends on how complex your data might end up being. And next, we're going to talk about incremental data loading real quick. So this is a really similar pattern to that feeding via API or messaging, except we're using asynchronous flows to launch multiple threads to do work rather than just working each item individually in a loop. This allows that data to be fed into decisions as processing power becomes available. The pattern is very similar to a work queue, except we're doing work on items from an external system rather than items directly from a queue. It can still utilize that queue worker within decisions and can even allow multiple servers to help do the work. We'll talk about how to configure these options later when we get into the platform.
All right, so we're getting close to the end here of these different patterns, and I promise you we're going to jump into those queues here in just a moment. But let's talk about leased entities and worker threads. Now, leasing is an interesting pattern. So this gets into the work queuing concept where we take the data in, but instead of processing that data, we're going to break it up into chunks that we want to work that data in, and then we're going to put it somewhere persistent until that work has been completed. Now, with leasing specifically, you will need to use a decisions leased entity structure, where you define the fields that you need, but that structure also automatically includes fields for locking and leasing that object. So when you go to work the items off, you have decisions say, give me one or multiple items and lock them in the table so no one else can get those items. So I would take the data in from whatever source. What needs to be done to massage that data into the leased entity data structure, and then I would batch insert it into the leased entity table, or that table that was created for that leased entity structure. Now, all this data, once it's been batch inserted, is going to be sitting in a database in a persisted state until Decisions is able to pull that specific record and start performing work on it. Now, when it's locked, it's actually being updated and values are being added. Now, if a thread happens to die or the server dies, when it starts back up, Decisions will start working those records again because any item that has not been worked will be sitting there in that persistent state in the database. Now, one extremely important thing to note here with this pattern, with using a leased entity structure, the table that's created for that structure is not meant to be used for long-term storage. That table is used to persist data until the work has been done and has been saved somewhere else or pushed back to another system. So as you're done working those entities, it's important that they be deleted from the table. All right, here it is, work queues. We are going to talk about a little bit and then we're going to jump into the product. So this pattern does share some commonality into what leasing does, where I'm going to take some data in, I'm going to break it into chunks or individual items. However, rather than pushing it into a database to be persisted until it can be worked on, I'm going to load it into a work queue, where again, that data will persist if there's a server rebooted. And I'm going to set up multiple nodes or servers to listen to that queue so that when data starts being loaded into that queue, each node can pull those records off and perform that work. I have the ability to also define here how many threads I want each server to be using for that specific queue. And this is going to spread the processing load across multiple nodes, where you're really going to see a big performance increase. Now, additionally, if one node goes down and the other node is still running, that work can still be happening on the available node. Now, rather than to continue to talk on this slide, I think now is a perfect opportunity to jump into Decisions and walk through setting up a queue, as well as the example we have built for you.
I feel like we need a drum roll for this part, Jess. Thanks. All right. And can you just confirm you could see Decisions here?
I can. So the first thing that we need to do before we can even start using a work queue, we've mentioned you need to have that enterprise license, but you also need to enable the enterprise module. And the way that you do that is you go into your system folder under administrations, there's a feature category. And typically where you would see this enterprise module would be on the right-hand side. However, we've already installed it, so you're seeing it on the left-hand side. And all you have to do is just click that little install button underneath of it. And then once it's been installed, you're going to have to restart your server, restart Service Host Manager. So this is where this module lives. It's very important that you actually have this enabled before you can actually get to the work queue settings. So now let's go look at some of those work queue settings. And as Kyle's navigating there, which is going to be under System, Jobs, and Events, and work queue types, one thing that I'll note is as soon as you install that enterprise module, Decisions is already going to add a default queue for you. And that's what we're looking at right here. And this is actually the queue that we're going to be using for our example. Now let's go ahead and pop into those settings and take a look at some of the configurations that we have here. Now, obviously, you have the ability to change your work queue name, so you can give it a meaningful name. We're going to just keep it as default today. But then the next setting that you have is how long do you want to lease the items in that queue? How long do you want to make them available in that specific queue? Now, by default, it is 30 minutes, but depending on your process, depending on the size of the data, depending on what work you're doing on that data, you might want to extend this time or tweak this time a little bit. And again, that's just going to take a little bit of testing and seeing where turning those little knobs and levers is going to work for your process. Now below that, we have a queue order. Oh, Kyle, can you go back in there? Thank you. So below that, the very last option we have there is queue order. So this is just saying, essentially giving your queue a priority. Which queues do you want to be worked first? If I have 5 queues, I might want to prioritize them 1 through 5. Again, we have 1, so we're going to leave the queue order at 1, but just know that you can prioritize these queues. So this is setting up a queue. But we also have the concept of work queue workers. And a work queue worker is going to govern how each server in the cluster handles work that is stored in queues. You'll also hear these referred to as worker profiles. Now, with this work queue worker or this work queue profile, just know that these settings that we're setting here, this is not specific to a queue. This is going to be specific to a server. So some of the settings that we have here is obviously the name of the profile. This should be something meaningful so that you know which servers should be assigned to that profile. We have check time span when active. This is the amount of time that will pass between checks for new work in the queue when the work is already active and has been processing work from the queue. By default, it's set at 5, but again, you might want to turn some levers and knobs here and see what works best with your process. Now below that, we have check time span when inactive. And this is going to do exactly as it sounds. It's just going to allow a certain amount of time to pass between checks for new work in the queue if the application server hasn't had any work to work on lately. Now moving on to the next one, pick up items older than. This is a pretty interesting concept here. So this setting specifies the minimum age of a task in the queue that this worker profile is allowed to pick up and work on. And the purpose of this setting is to allow you to have servers that don't normally work on background processes get involved only when the work queue is getting backed up and the servers that normally address that work or more aggressively addressing that work are taking too long to get to the tasks in the queue. And then if we scroll down all the way to the bottom, which we're already at, we have a thread definition type. So are we talking about worker threads or are we talking about API threads? We're going to be using worker threads because, again, we're not going to be pushing this data in via API. So Kyle, if you just hit that little drop down, you can just show them the different options they have there, worker threads and API threads. Then finally, the thread count. So this is the number of threads that the Decisions platform will be allowing you to commit to background processing. And the right value for this is going to depend on your hardware and the type of processing that you're doing. A good general rule of thumb is to look at how many cores you have on that server and divide that by 2. But again, this is another area that you might want to tweak and play with the different thread counts to get that performance that you're looking for. Now, the last area of settings that we're going to talk about is I mentioned, servers being able to tell which server the worker profile that they should use or how many threads that server is allowed to use in a queue. Now, the way that you do that is you go to System Administration, and then there's a Servers category or a Servers item that Kyle has clicked. And if we right-click one of these items here and edit that server, if we look at the very bottom, there's 2 different settings I want to talk about under work queues. The first is run all queues. So this is saying this specific server in our clustered environment or this specific node in our clustered environment is allowed to work on all of the queues. Or you might have a specific node that you have designated to work on a specific queue. So you can actually turn off run all queues and you can select the very specific queues that you want to allow that server to work on. Now, again, we only have 1 queue here, so we're going to go ahead and allow ours to run on all the queues. But then the next thing I want to talk about is the worker profile. Again, I mentioned you might hear work queue worker and worker profile used interchangeably. Again, this is just saying when this server is working things from work queues, which profile should it use? Meaning, How many threads is that server allowed to use while working tasks in a queue? All right, so I'm going to go ahead and turn it over to Kyle, and he is going to walk us through an example that was built out and show us a work queue or a process running using work queues.
Thank you, Jess, for explaining how we can get those work queues actually set up in decisions. So the example we have for you guys today is just a fairly basic example just to show how you might be utilizing work queues. So I'm just going to click into this main flow here, which is just a small project that we've built out. So let's go through step by step and talk about what's going to be happening in this process here. So this first step is called deserialized purchase information from CSV. So this is where we are uploading that actual spreadsheet that we are going to be doing work on for each line item. So that spreadsheet is just some purchase information. You can see the fields that we're working with up here at the top, and the total and the machine fields are going to be blank for each of these items when we upload it. That's because we're going to be calculating the total if it is an item that was purchased this current calendar year. And then that machine is going to be updating based off of which server is doing work on it. So that way we could see how much work was done by each server and prove that we are using a 2-node cluster here. So once we pass in our spreadsheet or our CSV, we're then going to be passing each of those items, each of the line items from our spreadsheet into this subflow here. Now, this subflow, we currently have it set up so it's running asynchronously. And over here on the right side, we can just talk about some of the configuration settings under this work queue option. So if I deselect that use work queue, then we have the option for manage execution threads. And this is how you could configure a thread job, if you were working this on a single server. But because we're using a work queue, we're going to make sure we have that option chosen here. And in our dropdown, if we had other queues to choose from, then we could decide which one we're going to be doing work with, but we're just using that default queue out of the box. So when this runs, this subflow is going to be queuing up everything in the background. And then once all that is queued up, then the actual process will start where we have workers doing work on each of the items that has been queued up. So what is that work that's going to be done? I'm going to drill down into this subflow so we can see what this process is going to be. So again, we're sending each line of that spreadsheet into this workflow here. And then we will be updating that field of machine with the name of the server that is doing work on it. So our current configuration is a 2-node cluster that is using that enterprise module so we can utilize work queues, and we'll just be updating that name with the server or the machine that is working on it.
Now, this isn't typically something that you would put into your processing flow. The reason that we're adding this get server name step is in a little bit, we'll be reporting on which servers actually worked which process. So we just needed a way to show the different counts. But again, this is not something that's required to use work queues. You don't have to get that server name. This is just for reporting purposes.
Right. This is just for proof of concept right now. And after we go ahead and have that server name updated, we're going to pass our data into this rule to see if the purchase date was this current calendar year. If it was, then we're going to be calculating the total price by multiplying the number of items by the cost per item. And then this is where things get really interesting, this batch insert entities auto queue step. So there's a few different steps that you can use in order to save data within decisions. You might use a save entities or a batch insert step, and that's going to be a little bit different from this auto queue. So on the right side, we actually do have some configuration settings for this. And what we're doing here, what we're telling the step to do now is every 10 seconds, go ahead and whatever data or whatever is in memory in decisions, call a database to save it to. This is just going to limit the number of database calls that happen. So if you were working with a process that had maybe millions of lines of items, you might not want to update that database all at once at the end of your process. It might make more sense to incrementally do it as you go along to make sure that you have that processing power free to still do work and save your work at the same time. So this is just the step we're using for this process, just because it makes a bit more sense for our design pattern. So after we send everything in through this, through our subflow, again, everything will be queued up in the background, work will be done, and then once we go through everything, our workflow will end up finishing. So we're just going to step into our debugger now. Again, that is our full visual testing environment that comes out of the box in our top toolbar up here, just so we can run our workflow and see how fast this is going to be doing things. Now, one thing to note is that when running a workflow in a debugger, it is a little bit slower than running it outside. So as this is going, we're not going to have it go through every single item live for you on here, but we are having our process running, and that's still going to be running when I close out of this. So now that we have our process running in the background here, what I'm going to do is I'm just going to go ahead and use this flow we have just called save pending. It just has a single step that's going to save whatever's floating around in memory to our database, just to make sure we have everything that's saved. And then we have a report where we're just reporting on everything that we have ran through that subflow. So let's go ahead and run this and see what has happened. So on our report, we can see what machine did that work. And then on this total, it should only be updated for the line items that are that year 2021. So just making sure our logic is correct here, and it looks like it worked as intended. And we have built a different view for this report, a matrix view, so we could see how many items were processed by each node or each machine in our cluster. So cool, we could see that this actually worked, and it was a fairly equal distribution here. Our first node processed about 48,000 items, and our second node processed about 54,000 items. So fairly even distribution of that work. You can fine tune this and add more machines to your cluster depending on what you're trying to actually accomplish here. But just a fairly basic example we have just to show that we are doing work across multiple machines when we run this process.
Now, before we open it up to any questions, or not open it up, because you guys are more than willing to ask questions throughout this, there's one other part of the platform that I quickly want to address where you can actually set up decisions to use a work queue. And that's going to be our scheduled jobs. So if you go on into System, Jobs and Events, and navigate to Scheduled Jobs, any scheduled job that you have in here, and we don't have one, so we'll go ahead and click New Scheduled Flow. We won't actually set one up here, but if we scroll down to the bottom, you have the ability to add a specific queue that you want scheduled jobs to run on. So again, maybe you only want your scheduled jobs to be running in the background. You don't want to kind of use the main processing. Feel free to, or I don't say feel free, I encourage you guys, if you're using queues, to have a specific queue for your scheduled flows as well. One of the reasons this is important is because let's say I have a scheduled job that runs at, I don't know, what time is it? 2:45 p.m. Eastern time. And that scheduled job might take a while to run because we're handling large amounts of data. And I have another scheduled job that's supposed to run at 2:50. If I'm not using different queues, if that first scheduled job isn't finished executing or isn't finished processing or isn't completed, that second scheduled job is going to be delayed until the first one is complete. So again, just another area of the product where you might want to think about using work queues. And with that, we are going to go and check our Q&A, check our chat. And let's see here. So which of the 4 to 5 patterns that you showed at the beginning did you use to create the demo? So the actual demonstration that Kyle went into, and maybe if you go ahead and open that back up, that flow, Kyle, we were actually using a work queue. And the way that we were doing that is with a async flow. And if he clicks on that async flow, one of the inputs there is the ability to use a work queue. So that's one way that you can use async flows. But just know this is a work queue pattern.
And
where
we have a
you're,
question that actually just came in the chat as well, just asking the kind of logs that our system keeps. So Decisions has a fairly good system with that. We do have a full logging and profiler, so any kind of errors or any workflows that are running in the system, you can report on what is happening in a more granular fashion. Jess, you're usually better at answering things like that if there's something I missed with that answer.
yeah, why don't we go ahead and just pop open our logs here.
Works for me. We actually have that saved up at the top here.
There we go. Awesome. So, by default, we do have all kinds of different things that will be logged, whether it be a warning, error, whatever the case may be. So if anything that's going on in your system, some sort of error or warning pops up, it's automatically going to be logged. But just know, and Kyle, I apologize if you said this, but just know you can also add custom log steps within your flows. So if an exception occurs in your flow, and you want to leave a very specific log message, you can use our step add to log, and you can define what that message looks like, and you can even give it its own category and level.
And this is found in system, admin, system tools, and then logging. And that's where you can find all the different things that store the data and decisions, our logging, our profile, our event viewers. So you can see everything that's running in the background.
Now, one other thing I forgot to mention here, if you, at that very bottom, if you kind of scroll up that horizontal panel or vertical panel there, you can see we're going to give you not only a timestamp, but a detailed exception message. These don't seem to be very detailed, but that's that full stack trace that you're going to get.
Yeah, it looks like this was just me opening that matrix report, so nothing to worry about.
All right, we will leave the line open here for a couple more minutes to see if we have any other questions that have come in. Now, as before we sign off here, I do want to also point you in a couple of different directions or resources. So we do have fantastic documentation available at documentation.decisions.com. So if you want to drill in any further about some of these details that we talked about today, I recommend you check out documentation.decisions.com. Additionally, this webinar is being recorded and will be uploaded to our website. And we have all of our previous webinars uploaded there as well. So we cover all kinds of topics. We do these webinars about twice a month and very specific topics. So I encourage you guys to check that out. If you're interested in how do I integrate with Salesforce, we have a webinar on that. As I mentioned before, we have that messaging queue webinar. We have integration webinars. We have webinars on just about anything you can think of. Now, with that being said, we are also always open to ideas for webinars. So if you go to our webinars page and you see a topic that we haven't covered, feel free to write us. Send us that information. You can email us at sales@decisions.com, info@decisions.com, and again, you can reach out to us on LinkedIn. Just let us know. What topics would you like covered? Additionally, I'll also say I mentioned some email addresses that you can email. I haven't covered support. If you have any support related questions, how do I use this step? I'm getting this error, whatever the case may be, you can always email support@decisions.com and they will be happy to help you out. And we'll see if we have any other questions that have come in here.
Looks like Corey's answering that last one real quick.
It's good to hear from you, Jeff. It's been a while. All right, again, we will keep this line open for another minute or two here. If you don't have any questions, feel free to drop, and thank you guys for joining us today and talking about work queues and different design patterns.
Yeah, thank you so much for joining us. And wherever you guys are in the world, good morning, good evening, or good night. And hope you guys will join us in 2 weeks when we're talking about mobile forms.
And it looks like, all right, it looks like we don't have any more questions. Let me double check one more time. I don't want to close it out too soon, but nope, I'm not seeing anything. So again, thanks guys. Have a fantastic day, morning, evening, as Kyle said, and we'll see you on the next webinar.
Take care, everyone.